Everyone is talking about Oman to India gas pipeline. Imagine a permanent pipe laid straight across the floor of the Arabian Sea. No ships, no waiting for tankers, just a constant flow of gas running day and night from one country to another. The Indian government is finally looking into it, but this has been around for over 30 years. It is called Middle East India Deepwater Pipeline Project, or MEIDP for short. But honestly, it has never made past the drawing board until now. We are talking about 31 million cubic meters of gas every single day. That is enough to power entire cities, but it comes with a massive price tag and some serious engineering headaches. The current record for deep sea pipeline is around 2,900 meters. But that's a small pipe. This project is a giant high-pressure trunk line, which is completely different ballgame. Years ago, the Blue Stream project proved that we could lay pipes deep using the JLA method. But this project is way beyond that. This route hits around 3,500 meters water depth. That is over a kilometer deeper than any existing pipeline. At that depth, the water pressure is 350 times of what we feel on the land. Imagine a fully grown rhino balancing its entire weight on your thumbnail. That pressure is pushing down on every square inch of that pipe. Not only does it have to survive that crushing force, but it also has to stay in one piece while hanging off from the back of a ship. A normal steel pipe would be crushed like a soda can. We need high-grade steel that is at least 30 mm thick to hold its shape and survive 35 megapascal of crushing pressure. Even with the best steel X65 or X70, it's a tight margin. Each 12-meter section of pipe weighs over 6 tons, and that is even before we add any protective layer to it. When you lay this in the deep, you will have 4 kilometers of pipe hanging from the back of the ship at once. And that is over 400 tons of steel dangling in the water. It's a bold project to say the least. But it's not just about the pipe and the steel. It's what's down there on the seabed. We have 5 major trouble spots to worry about. First, the Omani slope, which is a steep, unstable drop-off. Second, the Owen fracture zone, where two tectonic plates are literally sliding past each other. It's a rough, unpredictable seam that we have to cross. Third, the Indus fan, which is a massive underwater canyon system that is still shifting today. Fourth, the Kalut Seamount, an underwater mountain that engineers actually considered using as a base for gas compression. And finally, the Indian slope, which brings its own challenges with shifting sediments. We have a seabed that move and crack. So what ship can actually lay this pipe? We have 3 main contenders like Saipem 7000, the Solitaire and the Pioneering Spirit. These are the biggest and the toughest ships in the world. But here is the reality. This project starts at the absolute limit of what these machines were built to do. It's an extreme balancing act. With over 2,000 tons of pipe hanging off the back of the ship, we need incredible tension system just to keep the vessel steady and the pipe from snapping. Is it crazy? Yes. But is it impossible? No. The technology and the steel are already there. We do not need any new invention. We need guts to do it and experience to steer it. I have spent 39 years in this field and I have seen impossible gets built time and again. If you put me in charge of this one today, I'll have it done in 5 or 6 years. Any takers?